This star is dead, but it somehow refuses to disappear. And what it becomes after its death is one of the most extreme things in the universe. Small stars like our Sun do not explode right away when they reach the end of their lives. Instead, they slowly run out of fuel. And when that happens, the balance that holds the star together begins to break, and gravity starts to take over, pulling everything inwards. And then the outer layers of the star begins to drift into outer space, only leaving the core behind. And that leftover core is known as white dwarf. A white dwarf is incredibly strange, especially when you think about it. It's smaller than the Earth, but yet it could contain half the mass of the Sun. That means it's something the mass of the star, but compressed into the size of the Earth. The matter is so close to each other that even a teaspoon of this would weigh a ton on Earth. That's how dense and heavy this object is. The gravity on a white dwarf is very extreme. It is more than what we could experience in our entire life. It is so strong that atoms themselves get crushed. The electrons resist being squeezed further, creating a matter that cannot be replicated on Earth. It's not just dense, it's at another level of pressure than we could imagine. The atoms and matter behave differently at this level. As a white dwarf begins to cool, something unexpected happens in the core. The white dwarf slowly begins to cool. Its internal structure begins to change. The carbon and the oxygen inside it starts to arrange them in a very orderly way, slowly forming a crystal structure. In simple words, inside of the star begins to solidify, turning into something that behaves like a giant crystal. So, in a way, we can call this giant dead star a space diamond, and white dwarfs have a limit. There is a point where they no longer cannot support their own mass. If the mass adds up too much, it becomes unstable. The limit is about 1.4 times the mass of the Sun. This is called Chandrasekhar limit. Once a white dwarf crosses this boundary, it can no longer stay as a white dwarf. And what happens next is dramatic. The star collapses again. This time, instead of stabilizing, it explodes. This type of explosion is known as a Type 1a supernova. It is one of the most brightest events in the entire universe. For a short time, it can outshine an entire galaxy. Some white dwarfs do not stay around, they exist with another star. Slowly over time, they can pull gas, the things that they need from the other star. They are essentially feeding on it, little by little till they reach the limit. And they explode. And simply after all of this, the white dwarf does not still die. It cools over billions and billions of years, fading away step by step, a dead star that refuses to disappear.